Statistics have been a feature in SoundCheck for a very long time. But did you know that statistics can be used to overcome fit variation when measuring body-worn devices? Let's look at how we can use this feature to make repeatable TIA 920B measurements on headsets. For realistic and accurate results, headsets and other body-worn devices should be measured on a head and torso simulator, or HATS, placed just as worn by real users. Unfortunately, small changes in position can lead to significant changes in both the level and the sound quality, whether on a real person or HATS. For example, when placed carefully, the receiver of our USB headset sounds like this.
The jacket hung on the back of the wide chair.
When placed poorly, it sounds like this.
The jacket hung on the back of the wide chair.
To obtain repeatable results, we make several measurements and average the results using the statistics step. The headset is completely removed from HATS after each measurement, then repositioned for the next. With practice, 5 measurements are usually enough. This procedure is defined in ITU P.380 and IEEE 269 and used in Listen's pre-written sequences that implement TIA 920B. Let's make some measurements. We're testing a USB headset that has 2 receivers and a boom microphone, intended for speech communication. There may be some speech-sensitive signal processing, so the test uses real speech. The signal is played out of the receivers first, then to the HATS mouth.
The jacket hung on the back of the wide chair.
A pound of sugar costs more than eggs.
The coffee stand is too high for the couch.
The ship was torn apart on the sharp reef.
When the first measurement is finished, the received frequency responses and single parameters such as output level are shown on the top line. In a similar way, the side tone frequency responses are on the second line, and the send frequency response is on the bottom line. After 5 measurements, with repositioning between each measurement, we can see the individual frequency responses. Let's take a closer look at the left received frequency response. The individual frequency responses are in gray, the current measurement in white, and the current mean in blue. After the last of the measurements, we can see the mean results. Tolerances from the standard have been applied to the mean receive and mean send frequency responses. The standard deviations show the repeatability of the individual measurements. If the standard deviations are within the tolerances, the mean results are acceptable. When results from 2 or more operators using this method are compared, the mean results will usually be very close, even if the individual measurements are somewhat different. Statistics help overcome fit variation to make accurate and repeatable measurements of headsets, as well as most other body-worn devices, such as helmets, goggles, parrots, and so on. And if you're making TIA 920B measurements on such devices, you can save a lot of test writing time with our pre-written TIA 920B sequences. These can be used for USB, Bluetooth, or wired analog devices, and there are also open-loop sequences for testing devices that connect to a server.